Hello and welcome to an episode of The Central Equilibrium. I'm Eric Kai, the Chemical Statistician, and I'm pleased to welcome my guest, Arnab Chakraborty, who will talk about the Monty Hall Problem and Bayes Theorem. Arnab, welcome back to The Central Equilibrium.
Thank you for having me again.
Arnab was a guest on an earlier episode about Bayes Theorem. If you haven't watched that episode yet, I encourage you to do that first, and I'll include a link to that episode down below in the description of this video. Arnab earned his Honors Bachelor of Science degree in Physics and Statistics and a Master of Science degree in Physical Geography, both from the University of Toronto. He now works as a research associate in data development at Environics Analytics. Arnab, what's your overall objective for today?
Today, I'll be going through the Monty Hall Problem, and I'll explain one of its solutions as a continuation of the previous episode through Bayes' theorem.
Okay, and we're going to go through another solution that was mentioned in a column by Marilyn Vos Savant in Parade magazine, and I'll make sure to include a link to that column in the description of the video below. Okay, so Arnab, shall we first describe the problem and set this up so that our viewers know what the problem is?
Sure.
Okay, so I'll erase the board, and if you would be so kind to write down the rules and objective of this game.
So the problem gets its name from the host of Let's Make a Deal in the 60s, Monty Hall. So suppose you're in a game show and you have the host shows you 3 doors. Behind one of the doors, you have a prize. Let's say a pot of gold. And behind the other 2 doors are non-prizes, and we'll say that they're trash. You get to select one door, you the contestant. And the host reveals a door with trash. He then gives you the option of switching to the other door. So the question is, do you switch?
Aha! Okay, so let's draw a simple diagram to illustrate the setup of this problem. So we have 3 doors. Door 1, door 2, and door 3. Okay, so one of them contains gold, and the other 2 contain trash. In the beginning, we don't know which door opens to the gold. So the contestant chooses one door. Now let's say the contestant chooses door number 1. Okay? So the contestant chooses door number 1. The host then reveals a door that must open to trash. So suppose that the host opens door number 3 and shows that door number 3 has trash. So now the question is, should the contestant switch from door number 1 to door number 2?